Okay, so the focus of this video is going to be all on telling stories with position time graphs, and even more specifically, converting a story that we could write or that we could tell someone into a position time graph that communicates essentially the same information, at least about an object, or in this case, a person's motion throughout some journey or throughout some event. So, in this first example, we are told SZA is driving all around, and the first thing that I want to point out is that we're told that we are supposed to consider SZA's home to be 0. And we're told in this first part that her home is LA, right? So if I'm starting this and I want to make sure just to sort of make a note to myself about this, I want to just put a little sort of notification, home, and then this isn't necessarily something that you have to do, but it was a good habit that I saw some people, or like a good idea that I saw some people using in class when we were solving problems like this. So I'm just going to note to myself that this 0 line for this journey that SZA is going on is her home in LA. Now, just I see a lot of norths and souths in here, or at least maybe norths. As a reminder, when someone or an object, in other cases, is moving north and south, the general sign convention is that north is positive and south is negative. That's only because if we think about our compass rose as a coordinate plane, north is kind of like up on the compass rose, and so up we know is positive on a coordinate plane, and south would be the opposite. So if she starts out north of her home in San Francisco, or her home in LA, she starts in San Francisco though, I'm going to place a dot way up here, north of her home. I didn't know exactly where to put this, if I should have put this lower, maybe in the middle, maybe up top, but I know it needs to be up above her home in LA. She then drives further north to Oregon. Okay, so I'm going to undo this, and I want to move this initial dot down a little farther. And the reason for that is that if we're told that she's driving farther north, I don't want to start way up at the top of my position time graph. I want to move that down a little bit so that I actually have room to drive up to Oregon. She's driving here. But she realizes on the way up that she forgot her lucky bracelet back home in LA. So she rushes home. And again, home is this kind of like 0 position, this 0 line going through, or like the x-axis really, where we know our y or position is 0. And she does that really fast. There we go. She rushes home faster than she was driving before, back to LA. So if I want to draw her moving back to LA, I'm going to need to draw her, time going forward, but her moving back towards home. And I need to draw this line steeper than this initial part of her journey because we're told that now she's moving faster than she was before, which means it needs to be a little steeper. Okay, and she reaches home, and once she gets there, she takes a little while in her house to search for the bracelet. So for all intents and purposes, we know that she is moving around a little bit, but she really is staying home this entire time. Right? Her position is not changing by miles. She's not driving anywhere while she's at home. She's just moving around her house. So I'm going to draw a little line to show that she's at rest now, and she's at rest at home. So she could be at rest in other positions, but since she's home in LA and she's not driving anywhere else, time marches on, but her position does not change in this y direction. Then, after finding it, she drives faster than she's ever driven before, so I'm thinking steeper on this position time graph, all the way up to Oregon for her concert. So, let's do that in one last color. And she needs to drive very, very fast. So if she's driving faster than she's ever driven before, I need to make that steeper than any other part of this graph. And since she's driving all the way north to Oregon, then I need to have this final position a little farther north than even she got in this part of her journey, because in this purple line part, she was driving north, but then before she actually reached Oregon up here, she had to turn around, search for a bracelet, and get all the way back up north. So now I needed to draw this steeper to show that she's driving faster, and I needed her final position there to be a little farther in the positive direction, or in this case north, than she had ever been at any other point in this journey. And then the final thing that we're told is just that she performs for a few hours. I'm assuming that this is an online concert. Maybe it's her NPR at home Tiny Desk concert or something safe right now for people. But that's the end part of her journey where she's at rest again. Her position, the Y value, is not changing, but time continues to march for however many hours she's performing, for a few hours. All right. So that is our first example. One thing I just want to highlight, and I'll try to point this out in other examples, is the importance of defining where certain things are. So defining what the 0 is for this situation, defining north, south, east, west, whatever directions this person's moving, when certain things happen, like before she reached Oregon, she had to turn around. And that's kind of the level of specificity that we can communicate in these position time graphs that honestly often that we might leave out of a story even just by telling it. So when we write these stories that we then convert into position time graphs, it's really important that we are specific and include the important details. And you'll get a feel for what those important details sort of are just with more examples. So here we have an example. Ben Simmons is running up and down a basketball court. We're told that we consider half court to be 0. So just before I do anything else, I want to label half court on this sort of 0 line, or like home, or just the midline in our position time graph. We're told that he starts west of half court. So west, if we're looking at a compass rose as if it's a coordinate plane, west is kind of like to the left, which we know left on a coordinate plane would be negative numbers for the x-axis. So if he's starting out west of half court, he's starting out at a negative position. So I'll draw his initial starting point right there. Starts west of half court. He then slowly backpedals further west on defense. Okay, so before I even get to something else. Slowly backpedaling further west. So slow means that I need to draw this kind of shallow, right? His position is not changing a lot in a short amount of time. And he's moving west because he's moving further in this negative direction, further away from half court, in fact, because he started west and he's moving further west, so he's getting farther and farther from this half court line as time goes on. But then he steals the ball and immediately runs quickly east. Now, I'm going to do this right. Steals the ball and immediately runs quickly east. Once he gets close to the east basket, past half court, so the reason I wanted to read this next part before drawing is because I needed to know when I would stop drawing this. So I need to draw him running quickly here, and then we're told that he keeps running at about this pace even after he passes by half court. So let's draw him going past half court. And then he moves slowly to wind up for a dunk. Right, so once he gets to the east basket, he slows up to wind up for his dunk. But he's still moving east, presumably. He's just sort of gathering himself, not necessarily sprinting away from the defense, but getting ready to jump vertically. So he's still moving east, so his slope still needs to be positive, running towards our positive direction, which is east. But since he's moving slower, I'm going to draw this not quite as steep as where he was like sprinting away from the defense after he got his steal. Okay. Then we're told that he trips over a camera person. They're always way too close on the sidelines or on the baselines. So he trips over the camera person, and Ben Simmons temporarily comes to rest here. So if he's at rest, even though his position is not changing, time still continues to march forward. So let's draw a little flat line here to correspond to that part of this journey. And then at the end of this, he is sprinting back west of half court to play defense again. Now, honestly, I should have written a slightly more specific sort of speed or relative speed for Ben Simmons here. I'm going to assume he runs at a pretty similar speed to what this like cyan blue like teal color is. So Ben Simmons should be moving pretty quickly back west of half court. He's sprinting back on defense for the next play. I wish I had specified whether it was quicker or slower than this example where he's dribbling away from the defense, but I didn't. So I'm just going to make sure that I draw it definitely steeper than when we're told he's backpedaling slowly, but relatively steep. That's the end of that other example. Again, similar details here. We needed to define what 0 was. We needed to be specific about when certain things happened, about whether someone was moving faster or slower than they had before, when they came to rest. And those are, again, some of these key details that we tend to leave out when we might be describing a situation unless it's important for other pieces, but that we can communicate pretty easily with a position time graph, or at least straightforwardly, even if it's not easy. All right, so let's do one more example here. So now we have this example of Lauren, who is a brilliant psychologist now based in Chicago, which we are considering to be 0. So let's label this 0 for us. Chicago is home for this. So she then starts out here. That's what it sounds like anyway. Lauren is a brilliant psychologist who now lives in Chicago. She then takes a plane west to LA. So that to me sounds like she is starting in Chicago. I'll draw that. Again, Chicago is home. So if Lauren's starting there, she's not starting east or west of Chicago. She's starting right there at 0. She then takes a plane west to LA. So west, again, is kind of like on a compass rose to the left, which on a coordinate plane we know would be negative, where she stays for a weekend to give a lecture at UCLA. So let's draw that first. She takes a plane west. So again, west is kind of like negative, so she's heading in the negative direction. And then she stays there for a weekend to give a lecture at UCLA. So if she's staying somewhere, she's at rest, she's not flying or driving around, at least not too much. She's still based in the same city down there or out there in LA. So even though her position is not changing, the Y value is not changing, time continues to move forward, even though Lauren is not moving from LA, at least for a little bit. She then flies east, and farther east than Chicago. That's an important detail to let me know that I need to, when I'm drawing this, move her past Chicago. Excuse me. So farther east than Chicago, like more positive than her home here in Chicago. But she immediately flies back to Chicago once she lands in New York. Now there are two possibilities, maybe there are more possibilities too, of how you could interpret this last part. I will do it the way that I was thinking of it when I first wrote this problem. So she immediately flies back to Chicago once she lands in New York. So if that happens immediately, because she's so disgusted by New York, even without leaving the terminal, she immediately gets on a plane back to Chicago. Now, more realistically, and this is something that was pointed out in class when we did this example, chances are Lauren couldn't actually just get right back on another plane and leave immediately unless she's got some private jet, because that psychologist money has really been coming in. Chances are, if she's a semi-normal person, she probably would have to wait at the terminal for a little bit and then fly home to Chicago and come back to this 0 line. That's probably the more realistic story. So this black part that I've added to the position time graph is kind of like an alternate story. Maybe I'll do that in a dotted line. That's probably the more realistic case of what happens. She has to wait for a little bit for another plane to be going from New York to Chicago, and then once the plane gets there, she can actually take the plane. The way that I wrote this made it sound like there was some immediate plane back, but chances are the journey probably looked more like that dotted black line at the end. But again, that is All of these examples involve the same kind of analysis. Remember where your starting point is, define the positions clearly, make sure you know the direction of someone's motion, the relative speed of their motion. Are they moving really slowly and the slope should be relatively shallow, or are they moving really quickly and the slope should be relatively steep? And all of these examples could boil down to the same sort of key points of analysis that these three examples had.